Seconds and then you can speak.
Okay, hello everyone. My name is Azizullah Temirov, and I'm software engineer student from Tashkent. Today, welcome to our today's event. Okay, today's event theme is Kotlin Campus Camp, and let me give speech to the Askar Aitov. He will introduce short.
Hi all, thank you for joining. This bootcamp is organized by Google Developers Group, Turkey and Central Asia. We have a big region which is part of Google Developers Group. Here is our DevRel team. Is Baris Sugey. He is program manager for this region. Beyza Sunay. She is responsible for Turkey and Azerbaijan, and for Central Asia, responsible is me. And we have this massive bootcamp dedicated to Kotlin and Android. It's fundamentals. If you finish 4 modules on this website, you can go to it or you can copy it. I will put it to the chat as well. If you finish 4 modules, it's not difficult. You get badges from Google developers, and also you will get a certificate. We will send a certificate. It's super easy. One guy did it in like 3 days. Also, we have upcoming machine learning bootcamp. It will be providing you free access to Cloud Skills Boost preparation for a certification. Please subscribe to our YouTube channel for more bootcamps, workshops, and you can locate events near your city using this website, gzg.community.dev. Thank you for joining today and good luck with your study and career. Thank you.
Thank you, Oscar. Let me introduce our today's main speaker, Alexander Nozick, Director of Scientific Programming Center. Hi, Alexander.
Oops, I forgot to unmute my microphone. Hi, everyone. I'm very happy you invited me to give this talk today. So probably we should start. First of all, I will ask Oscar to share my screen because I can do it myself. And I also prepared, and yeah, here is the link. And I hope you will be able to follow me on this data lore. I will explain what it is. So you can just enter this link and register. You can use your Google account to register. It doesn't require a lot. And then you can follow what I'm doing and then practice yourself with the same notebook. Just copy it yourself. So today, and of course, do not forget to ask questions because this is what we are here to do after all. Okay, so here we see some users joining me in my notebook. Today we will be talking not about Compose. Today we will be talking about Kotlin language. And of course, it's not possible to learn the language in 1 hour or even in 1 week or even in 2 weeks if you do not have a lot of previous knowledge. If somebody tells you that they can teach you a language in, I don't know, 3 hours, they probably just want your money. But what I want to do today is just share some specific points of Kotlin, specific differences, which are important to understand what Kotlin primary features are. Some features, not all features, but some features. Kotlin is a rather complicated language. And I decided to use graphics to explain it. One of the most complicated thing in learning Kotlin, learning Android and other tools in Kotlin is the build system. And we do not have time today to learn it, but you will have to spend some time, maybe 2 weeks, to learn proper build system. But since we do not have time today, we will be going we will take an easy route, and we will use a Jupyter notebook. Jupyter notebook, you probably know what Jupyter notebook is if you're worked with Python at some time, but there is also a Kotlin Jupyter notebook, which allows us to use almost all features of Kotlin language from notebook environment without setting up build tooling. So let's begin. Today, I wanted to show you drawing some pictures, actually, and we will be creating buttons, at least pictures of buttons. They're not clickable, but at least it's similar to how graphic user interfaces work in real life. First of all, I'm loading this library. One of the important features of Kotlin ecosystem that it relies on Maven dependency resolution and the Maven repositories, which is very quite robust. And in order to load library, you need to just point to where this library is in the Maven central repository or other repositories as well. You can load repositories. In the notebook, we do it with one line. We just create an annotation. In Java and Kotlin, annotation begins with this symbol. And point the coordinates. Here we have a package, the artifact name, and the version. This is very important because you will have to rely on libraries. So we have loaded this library, and I've created a very simple function based on this library. This is a J-free SVG library, which is part of J-free chart library, Java library. Actually, it's not Kotlin library, it's Java library. And it allows us to create SVG images, which are then rendered by the Kotlin notebook itself. What I'm doing here, let us check. I'm creating my first function. Of course, in order to create it, I need imports. Here, imports. It won't work without imports. And then I have a function with the parameters, and we have some language features here immediately. Like, for example, default values. Yeah, we have a parameters function parameter with default values. And what is most important, we have a function as a parameter. Kotlin is a language which leverages working with the functions. And we have a function literals, function types. Here we have a function type like this. And here we have 3 places. We have a receiver. This thing before the point is called receiver. This thing in round brackets, there could be some arguments here, like, I don't know, string, whatever. This is called parameter, and this is called result. Those are types. What is different from, in most of languages, you have parameters, and you can call it some names. And there is a return type. Unit is a specific return type, which is roughly equivalent to void in Java or C++. I don't remember. In Python, there's something similar in Python, I believe. No return type at all. And what is new in Kotlin is this receiver type. We will discuss it later. And here, this function returns my type result, which is the part of Jupyter framework itself. Then the body of the function, as you can see, Kotlin follows Scala, or if you want Pascal notation, where a type is on the right, not on the left, but on the right. But type is important. Sometimes you can avoid writing types. We'll probably see some examples of this. But in general, you need types. And here, what we do, we create an object. In Kotlin, there are no keywords for constructors. Constructors are just usual function. So we create an object of type SVG graphics 2D with a given width and height. Then we use apply function. Apply function just uses this function and applies this block to this function. You can, if you work in IDE, you can control-click on this function and see how it works. We can check it later in the documentation if you want, if you have time. And then I apply this function. I apply this function to this object and then return an element of this function. This construct is rather frequent in Kotlin, so you need to be familiar with this. And in the end, I just return again the MIME object, which have a MIME type and the string representing this object. By the way, I can also set the specific type. It's not necessary because Kotlin allows us type inference, so it infers the type of this function. And if we can just place it, I don't remember, yeah, control space here, and in IDEA it's also control space, but in, for example, in normal Jupyter it's tab. And we can see that this function could take some arguments and return string with a question mark. Question mark, this means that this return value could be null. Without question marks, Kotlin types mean that they could not be null. And in the end, we return this pair. 2 is also a function. It's called infix function. It's just, I'm telling you a lot of terms, and it's probably very hard to grasp them all in the same moment, just for the reference. So what is important is that I've done this function, this compile. There are no errors. If for some reason I broken the type system, for example, I can run the double here and try to compile it, and I will get immediate error. This is different, for example, from Python, where you do not have a type checking algorithm, and you will have error when you try to use it, not when you declare it. Here, I do not have this problem, and it's a great feature for all types of languages. And let us draw our first button. Here is it. We call this function. Let's, for example, do it in a more complicated way. Let's call it SVG. And we call this function. And here is the one of the main difference. If I call this, nothing happens. As output is empty. But if I write it here, the output is button, because the last statement of the last expression of the cell is shown in an output. Here, since the output is actually a MIME type result, the Jupyter transforms this object, MIME type result, into the MIME. It's in this case, I believe I can show the exact output. I don't remember how to do it, but it's not that important. And it shows as SVG. We can, for example, try to inspect this code and see that this is actually SVG inlined here. Okay, but what happened here? The function should take 3 parameters, and instead I wrote curly braces after the function name. This is one of the very special features of Kotlin and Groovy language. Groovy is older, Kotlin is newer. What I written here could be written in the same way by introducing round brackets and adding block here. It will work the same way. So I can skip those parameters, but I can write them actually. Let me do it. Oops. Let me do it. Width should be something smaller, like 200, and the height is even smaller, like, I don't know, 80. Let me check. Aha, okay, it's much smaller. And I can skip those names, and I can even skip these names because those are positional arguments, and it's okay, it's working, because first argument is width, second height, and the third argument is a function. What happens in the curly braces is a function. Now let's, but what Kotlin does, it allows us to mm, if the last argument of the function is a function, then you can instead write it this way. You can move around brackets to only the first parameters and leave the last argument in those curly braces. This is very important, and it's particularly important for Compose because Compose is fully built on those trailing lambda functions. The feature is called trailing lambda functions. All user interface construction in Compose is built using those trailing lambda functions. So let's see what happens inside. Inside, I can write usual Kotlin code. For example, I can do println and write a string, whatever, and compute it, and we'll see that this line is printed. But this function does not require anything. But this function set color, if I call it outside, let me just try to move this function outside and call it, and I will get a error because nobody knows what set color is. So what is set color? Set color is a function of this SVG graphics 2D. Let us do a nasty hack and use a Java reflection to see what methods are there inside this SVG graphics 2D. I use you can see that I have autocomplete because Kotlin is a statically typed language. I know the type of each property and function I call, and so autocomplete is very useful to program, and let's use for each and print all those things. And I will explain what happens here. Let's just call it, and we see a lot of functions in this class, SVG graphics 2D, which includes its return types and it includes argument types. So what happens here? Here is some kind of Kotlin compare intrinsic, which allows us to call runtime class of this. Not actually runtime. It's a compile time class of this thing, and then we call the Java class, convert the Kotlin class to Java class, and then we use methods, and then we use a function for each, which is not a inbuilt feature of the language. It's also a function which takes a function and applies a function like this to all elements inside. This is how it works. You can probably check the documentation. It's pretty expressive. I mean, the Kotlin language documentation on the official site, and it expresses how it works. So we have a lot of things here, and we have a set color somewhere. Probably can just search set color. Here it is. This is function. It takes Java AVT, abstract window toolkit color, and uses it to set the current painter color. So this is exactly what we doing here. As I said, receiver is something specific. Receiver is an implicit type on which we call the code inside. So when the code we use, for example, keyword this here, we use these receiver type. Understanding receivers is quite important to work in Kotlin because, and understanding scopes, here we have a scope created by this function, is quite important because a lot of idiomatic language use is based on scope, especially in new frameworks like Compose. Okay, so the rest is very simple because what we do is we create this SVG. We can remove these things because we just create these things and return it. So we create a rounded rectangle where 10 and 10, it's a position of top level corner, 100 is the width, 20 is the height, and the 5 is a rounding of the corners. And then we add the string with a given position. And here we are, we have our first button. Now let us try to do something more complicated. For example, let me clear output so it won't load now we want probably to do something like a button bar. What do we need for that? We probably want to create something like a class for our button, because we want a lot of buttons. We do not want to replicate the code for all our buttons. So let us create a class. SV usually Kotlin does not like when Kotlin standard style does not like abbreviation to be all in capital letters. So let us call it this way: SVG button. And this button will have some parameters. What do we need? We need width. And let it be a number for to make it easier. Let it be height number, and probably we want text. Let's start with this. It's very naive. In real life, of course, it's not very simple to build a user interface, but let's start with a very naive idea. Text, it's a string. Okay, we can create this button, and the class is created, and then we can create these a function to draw this button. And yeah, that's all. We need to write. And we can, for example, we can do it this way by just copying it here. The only two drawbacks of Datalore is inability to check documentation, and at this moment it's not possible. And usually you can just use Control Q in Windows layout to check the documentation of any function. In this case, this does not work. And the second thing is automatic indentation, which also works much better in the IDEA or Android Studio, whatever you want. So we probably color. We want color as well. And let it be by default. Let it be black. You see, autocomplete helps me because I don't remember what colors are there. So I'm setting a color, and we need to use a color button color. Why doesn't it work? Okay, I need to recompile the cell. Okay, so I start to write, and I check that autocomplete works fine. Then I probably need to write those offsets as 0, because we do not need any offset. Here I write width. Here I write height. And rounding brackets, rounding corners are all the same. Next, I need to write the I need to write the string, which is button text. By the way, I wrote the wrong thing because I need width and height are not properties. They probably are properties of this scope, but I need to call button width and button height. Yeah, this is a property. Okay. So now it will work probably, but I need to not only to create SVG, I need to return as a function result. I can do it like this. And right here, meme type result, and it should probably work. No, it's not. Aha, aha. Yes, this happens. What happens here is typecast here, because I wrote here number here, and I require integer here. This is the problem because it's a number of pixels. And in Kotlin, as well as in Java, it's not allowed to cast automatically cast numbers. So you need to explicitly say what you want to do with this number. In this case, I need to cast it to int. Otherwise, it won't work. It helps you to avoid a lot of mistakes. Now it works. And I probably can create button and draw it. Let us try. Val button SVG button. Where is my autocomplete? Yes, here it is. And I need to add those properties like width. The width, ideal width is 120. Let's keep it this way. And the word hello. I'm creating a button that does not do anything. So now I need to draw a button. And oops, something went in the wrong way. Why it happens? Because I use absolute offsets, and here I had a offset of 10, and I need to reduce offset of the text. So it should be 45 and 15 here, and it's ideal. So we have a pretty nice button here. But we can somehow reduce the clutter a bit by, for example, using another simple Kotlin feature, using function declaration as an assignment. It's exactly the same. If you have a single expression function, you can assign function to its result. It allows you to save several lines. It's not critical, but it is sometimes it just looks better. It's not a common practice to do like this, but I like to simplify functions when I can. But it's not a not everyone follows this practice, just so for you to know. So now we create class, but you see the problem. The problem is that you need to know, because since we create absolute offsets here, we need to know the offset of the parent object in order to make proper offsets here. For this, let us get back and add some additional code. For example, by the way, let us check another feature here. Let us see what button is. Button is something a little. We don't know what it is. It's some kind of. It says us that the parent class, which is one of the Jupyter classes, SVG button, and it shows us a hash code it's not useful. In order to make it useful, we need to add one word. We can override a toString function to this button, but we can make it easier by adding data class. Data classes is a very it's not a major language feature, but it simplifies simple operations a lot. It adds some things like automatically generated toString hash code and some copying functions to the classes. So now when we do it like that, we will see expressive on toString, we will see the content of the class. Showing the type is the same as using toString methods. It's exactly the same. Okay, now let's get back and add some kind of context to our drawing. Let's call it class. Let's call it SVG layout. And this layout will have only, for starters, it will have only simple two simple fields. Let's call it value x offset. Let it be number. It could be let it be integer, because we are working with the integer numbers. It's okay. And value offset. For now, it will be not. The idea of this layout is to show the button where the offset is. We can call it also a data class because it mostly stores the data. Now, in order to draw something, we need to draw this button in the context of this layout. Let's do it this way. As you see, I add this function as a receiver. It's the same syntaxes as in function types. The receiver is before the dot, and it means that inside this function I can now access fields of this layout. Let's check this. This dot x offset. Okay. This won't work because this is the scope of create SVG, but I can write either like this, x offset, it's accessible, you see, or I can use type tag to access external scope. As I said, understanding scopes is quite important. This will be like this at SVG, this at draw, and here I have x offset and y offset. So I access the scope of not create SVG, but of function draw. Each function creates its own scope. So now what I want now is to use this offset here, like x offset, y offset, and here I need to add x offset plus and y offset plus, and it should be fine. Yeah. Now, if I try to call this function, it will be an error because I can't call draw without a receiver. So I need to create this layout. By the way, before I moved, okay, I will show you, but when we will return to understanding what receiver does. And let's be 1010, and now we can call layout oops, layout, draw, and it works perfectly fine. It gives us an offset, and it's pretty. An important note is that this receiver here does not add this function draw to the class SVG layout. Like, for example, it could work in JavaScript or Python where we have a monkey patching. It's not monkey patching. It's a static dispatcher. It means that this function is resolved during compile time. It is maybe it's not very important at the start, but when for it's quite different mechanics, and you need to understand this. Okay. Okay. Let us, if there are no questions, let us move further and understand what else should we do with our layouts. We probably want some kind of to create multiple buttons in one layout. For this, we need, if we do a second button here, for example, let us try this and call it button 1, and create a button 2, and it will be like hello. It's not hello. And we'll try to draw 2 buttons at once. I'm not sure what will I actually know what we will see, but it won't be pretty. We will see only the second button because we return the result of this thing, and this one is not used. So not good. We can't create more than one button. So how we can we solve it? In order to do that, we need to modify the way this function works. We need not to create a MIME type result as a result of the draw button. We need to store our somehow store the function that draws the buttons inside our whatever draws them. So let's try to do this. We need to create a drawing context. By the way, it's exactly how it is called in Compose. Call it SVG drawing context, and this class will hold this SVG. How it's called? It will hold SVG graphics 2D inside, and we need to create it. Let's copy some things from here, and it will have these parameters, but also it will have a graphics. It's SVG graphics 2D, and this. Let me again copy something from here. I need to use width and height for this. Okay, nice. Please notice that I use, there are different things here. I use value here. It means that the graphics could not be reassigned. So I can't create and then let's just try to do it. SVG graphics to SVG drawing context, and then we create it. And then we can try to access graphics. Context.graphics, and we can assign it, and we see this toString of this graphics. But why it's okay. But if we try to assign it, for example, like this, we will have 2 errors. For example, we can't use null because this type is non-nullable in Kotlin, and we can't reassign it because val can't be reassigned. If we do var and do proper SVG graphics here, then it's okay. So I need to recompile this. And it, oops. Aha, because it requires positive value. Okay. It's useless, but yeah, it works. But I do not want it to be reassignable. It should be used only once. Then I need to add a draw function, which will result in a meme-typed result as I've done before. Let's do this. We add a function here, draw, and it will like this, and graphics get SVG element. Yeah, here it is. So now we need to be able to draw functions to draw some new things, to add new things to our drawing context. For example, we can add a function like button. SVG button. And the same way we've done before, we create, we use those properties like here in a function, not in a class, but in a function. By the way, I'm doing right now, I'm exactly following the logic of Compose or React-like application. They do not use classes, they do use functions. So I'm exactly following the path to how Compose works. I do not need vals here because it's not a class, it's a function. Oops. And it's pretty nice, and we can copy the logic here. Just let us use it. We probably need, in order to get this x offset and y offset, current x offset and y offset, we need to store it inside our drawing context. So let's do this. And here it will be variable because it will change as we add new things. We will call it private because we do not want external people to access them. Private is bad. It's better to do it internal. Variable x offset, and it will be int 0 from internal variable offset int. It will be 0. Okay, I think it is enough to yeah. Aha, aha. In order to call this, I need to call it in graphics. So I either can do it like this, but like this. It should work. Color. Aha. And somewhere is spelling there. Yeah, now it works, but it's not very good. It's not does not look good because we use graphics 3 times. We can create a scope where graphics is a receiver. In order to do this, let's do it this way. We do read graphics, and the thing is actually the same in Pascal. You can. It was somehow inspired. I think it was inspired somehow by Pascal. So I can just clean this up. And it's the same. Okay, we have most of things we need to. Oops, sorry. I got so excited, so I dropped my microphone. I've got all things needed to actually create a button. Again, the same button. Let us do this. SVG drawing context. SVG drawing context, and we don't need to do anything. Then we need to call apply. So we want to do things in the scope of this thing. Call it button. We have a button function inside. We create this. This is called extension function. The function which a top level function or even a member function with a receiver is called an extension function. We call it button. And we pass our favorite numbers like 120 and word hello. And then we need to call a draw on result. Oops. Yeah, okay. Here we are again. It works. So this thing is very close to what we have in Compose, but we can do even more. We can, for example, we have 10 minutes and we can create offset. For example, we do not want to create button at the top level corner. We need to create offset. We can do it in 2 ways. We can increment offset whenever we create the button, and probably we should do this. If we want to vertical view, we will probably have to increase offset of Y offset by the height of our button. Let us do it. Y offset plus equals height to integer. It should work. And now we can try to do 2 buttons. Let's try it. Voila! We have our first 2-button bar. And we can even say hello. I don't know. Hello 1, hello 2. It's simple, sweet thing. And it works. Now we can also add spaces. Let's do this. Fun, SVG, drawing, just copy this thing. Vertical space and height number. And all we have to do is to add offset height to integer. And let's do it vertical space, like, I don't know, 5. And here is a space in between buttons. Exciting, isn't it? And now what we want probably to do is to create groups. We want to create groups of our buttons or whatever we do. In order to do so, we need to create a new context with the offset. Let's do this. Fun. Again, I take in this context here, and let's do a group. And do offset here, x offset number, y offset number, and mm, mm, function. A function that will take this context and modify it somehow. Let's call it block again. And what we want to do is to create a SVG drawing context with a current. It's a bad thing. Let's call it new x offset. Or add x offset, because we need to keep our, this will be x offset, which is available from this scope itself, plus add x offset to integer. Probably I should move those things to properties as well. Okay, let's redo this thing a bit. I probably want it to be an interface. I need some things to do, an abstraction for this thing to draw in, and let's call this thing like, I don't know, simple thing. And graphics, of course, we need graphics. Okay, and I need to add override for this to work. Let's check it. Okay, some problems here. Let's check what the problem is. I forward there. Okay. Since I can't switch it, it's okay if it is this. And why it is that should work. Why it does not work? X offset overrides nothing. It should work. I think it's some kind of problem with Jupyter. I should probably just restart the kernel. To clean up all old versions of the same class.
Oh, here someone wrote maybe because you have var and val.
Yeah. Val means value, var means variable. So if you have a val, you can overwrite var with val because it's more broad thing, and it should work. I'm not sure why it does not. Okay, let's clear this one, and this one should work. Now it's working. Yes, as I said, it's some kind of problem with the Jupyter class cache because I was changing the structure of the classes a lot, and for some reason I remembered the old version. Now it works perfectly fine, and it should work. Now I need, so I probably should use var as well, but it's not very good from the architectural point of view, but since I'm changing the position here, I need it to be variable. So the last things I need is to bring my API back to, I'm creating a function starting from the capital letter. Capital letter functions are not good because of Kotlin code style does not allow it, but it allows it if it is a so-called fake constructor. So we're creating this class, and we are passing if and hate. It looks a little strange because it looks like we have a constructor for interface. An interface can't have a constructor, but in this case, it's not a constructor. It's a function that which looks like a constructor in Kotlin. Constructor and the function, they behave the same way, so there's no difference. Okay, probably everything else should work. No. I didn't finish to write it. X. I'm creating a new anonymous object here and implementing it right away. And I need to override all those three methods. Just let me copy them. Plus add subset. Here. Same goes here. Okay, and graphics, we just need to inherit it from the parent. Now we need to apply this function to this new object block, and that's all. I don't need to draw because it reflects changes to the parent graphics, so it should work fine. Let's check it. So we created two things. Now we need to do a group, and probably need to set a default offset. to 0. And let's try it. Oops. For some reason, it did not work. I'm not sure why. It should create. It created X offset. Probably I somewhere I switched X and Y. Let's check. This one is correct. Because it created X. Yes, it should be X. Okay, sorry. It's my problem. There we are. This is what I wanted to do. Okay, this is the final thing I wanted to show you. So we can now create buttons and we can create layouts and we can shift one layout relatively to one another. And we use functions to do all this. Again, when you start studying Compose, you will see very similar things. It operates mostly in the same way. It uses functions and in Compose, those functions are starting from the capital letter because it is similar to how Flutter works, and people are familiar with this. But in general, it is the same. You use functions, and those functions are used to declaratively say how to draw your user interface. Now, if there are any questions, we can discuss them.
Okay, let us guys know if you have any questions related to theme. I think so far we don't have. Oh, here we question. This platform is only for Java programmers. Can I switch it to another one, be it Python or SQL?
The data lore is mostly for Python developers, and in enterprise regime it allows SQL, but it is the first notebook, cloud notebook, which allows Kotlin. I know that there is some work with a Google Colab switching to Kotlin as well, and I believe the data lore also is available for R and Scala as well. There are a number of the different cloud notebooks, but Datalore is exciting because it allows Kotlin.
Cool. And here one more question. In the beginning, what was the difference between draw function and svg layout.draw function? Is draw
Again.
function a method of a class?
Yes, as I said, it's a code extension function. Let's just switch back. This draw function is not a method of the class. It behaves like a method of the class SVG layout, but it is called extension function. You use it in this regard, you use it as a method of the class. But in reality, the compiler in compile time searches for the receiver and converts it to a static call. What you call it in Java, you call it a static call. So yes, it looks like a method of the class, but in practice it is not. This is the benefit.
Gotcha. Okay, here one more question from Hassan Rashidov. Is Kotlin better than Flutter.dart? Are there any advantages of Kotlin over Flutter, for example, in terms of size, speed, or so? I think they are two separate things.
Yes, the Flutter is the framework, and the main aim of Flutter is to provide user interface, cross-platform user interface for mobile devices and for desktop and for web as well. Kotlin, Dart is a language, and Kotlin is a language. So Kotlin itself does not provide you user interface. It's a language. it's a common belief that Kotlin is general much better than Dart, because Dart is mostly one framework language. You won't probably write anything but Flutter in Dart. I don't know about its future now that Google also supports Kotlin as well. But Flutter is a robust framework. It's pretty nice. There is nothing so feature rich in the Kotlin ecosystem right now. There's a compose which allows you to create your application for Android and desktop. But if you go to macOS, iOS, or web, the compose does not work, at least without changes. There is a compose web, but it does not use the same components as the compose for Android. So if you want creating a user interface for all devices, Flutter is probably better. If you want more robust language for your logic, more robust library ecosystem, Kotlin library ecosystem is tremendously larger than the one for Dart because it includes all the libraries from Java, all the libraries from JavaScript, etc. You definitely should go for Kotlin. I know there are some efforts to use Kotlin with Dart, with Flutter, but there are some problems with it. So it's not fully done right now. In terms of size, speed, and so on, there are no significant difference. Of course, if you do not take web application, because, for example, the Flutter web application will be huge because you need to take all this runtime with you. And Kotlin for web, I mean, Compose for web, for example, or React Kotlin, they use a native native components. The same goes for iOS. Flutter for iOS requires a huge binary, all this all those tools for drawing, and Kotlin application for iOS usually use native components. It's a just different approach.
Gotcha. I think we don't have any more questions. Okay. Thank you for being with us today. I hope it was very useful event for everyone who interested in Kotlin. And thank you so much, Alexander.
You're welcome. Call
And
again. Call
don't-
again. It was very nice to. It's some kind of question. Yes, of course. The answer to Ilyas, of course, today was just a demonstration. You should not do your user interface with a SVG, definitely. I just showed how it works inside. Yeah, so sorry, I interrupted you.
No problem. All right, guys, subscribe to our pages on social media and see you soon in upcoming events.